Good day and welcome to the Math Salon. My name is Dr. Anumendem. Today we'll be looking at two paper 1 mathematics questions for the advanced levels. So the first question says, given that the roots of the equation 2x squared minus 4x plus 3 is equal to 0 are alpha and beta, evaluate this expression here. So if I look at my expression, it's made up of the roots of alpha and beta, and the idea is therefore somehow use some relationship between this alpha and beta and the coefficients here in order to be able to work this out. We already know from the past that x squared, and also some other videos that we did before, that they have an equation as ax squared plus bx plus c equal to 0. Then this equation has roots whose sum, alpha plus beta, is equal to minus b divided by a, and whose product is equal to c divided by a. So if I use that idea, then I can try to see that my equation given to me is of the form ax squared plus bx. So I can say this is a here, this is b here, that is c. Therefore, alpha plus beta is equal to, b is minus 4, so this is minus 4 divided by a, that is 2. Minus and minus is plus, so 4 and 2 is 2. And the product is c divided by a, so that's 3 divided by 2. So now I'm left to solve, to get the value corresponding to that expression. If I look at that expression, well, I see that I have alpha here, also have alpha, beta here, also have beta. So I can try to factorize. Because the only information I have is this, I have to try to make sure that, I use that into my expression. So I have to try to manipulate my expression so it looks like this, like making something beautiful. You can play with it. And that is the math salon. So alpha, beta then, if I factorize alpha and beta from here, 1 beta alpha remains. Plus, if I remove alpha and beta here, 1 beta remains. And this is equal to, the product of the root is 3 or 2, times the sum of the root is 2. So this is equal to 3. The 2 cancel off. For the second question, they say, find P and Q given that 2x squared minus 12x plus 21 is equal to 2 into brackets x plus p squared plus q. If you look at this very well and think again about some previous knowledge that you had in lower 6 or maybe in form 5, you would remember that this is what looks like the completing the square. So actually, if you complete the square of the left hand side, it should be an expression like this. So I'm going to propose that we do it two ways. One will be expand the right hand side and use the idea of equality of two polynomials, which means if two polynomials are equal, the coefficients corresponding to the corresponding powers of x should be the same. Otherwise, we also use the completing the square and just pick out this p and q. So we will start with the completing the square part. That will help you also solve other questions that will require you using completing the square method to do. So our equation is given as 2x squared minus 12x plus 21 equal to 0. Sorry, that's not equal to here. I will just use the right hand side. I will do it at the end to equate it to the right hand side. So we just keep that. If that is the case, to complete the square, the first thing we do is that we try to make the coefficient of x squared to be 1. I give an example. If I have x plus a squared, then this is x squared plus 2ax plus a squared. Actually, this a squared can be written as 2a divided by a, all that squared, which means I take half the coefficient of this x and square it. If I do that, then this goes back, so I can say that the square has been completed. We will try to apply the same idea here. So in order to do that, first we have to make the coefficient of x1, because that's easy, that's the way. This is not an equation, so I cannot divide all through by 2, but I can play. I can shift the hair on one side and dye the other, and so this way I have 2 here, then I have x squared there. Of course, I factorize 2 outside, so I have to reduce this. So I get minus 6x. That means if I open this again, then this is 2x squared minus 12. So I divided that by 2. And we get plus 21 here divided by 2. But in order to maximize the space on my board, what I will do is I will shift this term a bit further and create space to play a little more. So here, let me say I put here 21 on 2 here. What is left is to add an expression here that will complete the square of this side. But we just learned here that to complete the square of this, just take half the coefficient of x and square it and put it there, you get that. So half the coefficient of this, that is minus 6 on 2 squared. But I just added a new term to this. It was not there before. So that is not fair. To be fair, I have to remove it. So I remove it. So in that case, 6 on 2 is minus 3. Minus 3 squared is 9. So minus 6 on that gives me that expression. And we know that, okay, what will be done is simply that we put that together. Say.